Hello, and a wonderful, warm welcome to all of you tuning in today. It is truly a pleasure to have you here. Before we embark on a journey to explore one of the most profound and mind-expanding concepts in all of cosmology, I want to take a sincere moment to wish you and your loved ones the very best of health and happiness. However your day is going, I hope you're feeling good and ready to stretch your imagination. Because today, we're talking about the ultimate stretch, the stretching of the universe itself, and how it's doing something that seems to break all the rules, expanding faster than the speed of light. Now, if you just felt a jolt of confusion, that's a completely normal reaction. We just finished talking about how the speed of light is the ultimate cosmic speed limit, the one rule that nothing can break. And that is absolutely true. Nothing can move through space faster than light. So how can the entire universe be expanding faster than light without breaking its own most fundamental law? The key to unraveling this incredible paradox lies in understanding the subtle, but crucial difference between moving through space and the expansion of space itself. It's a distinction that changes everything. Let's start with what we mean by the expansion of the universe. It's not that galaxies are like rocks exploding out from a central point into a pre-existing empty void. Instead, imagine the universe as a giant, fresh loaf of raisin bread dough. The dough represents the fabric of space itself. The raisins represent galaxies. Now, as you put the dough in the oven, it begins to rise and expand. Notice what happens. Every single raisin starts to move away from every other raisin. There is no center to the expansion. The entire loaf is just getting bigger. A raisin on one side of the loaf sees all other raisins moving away from it, and it would feel like it's the center. A raisin on the opposite side sees the exact same thing. Now, crucially, the raisins aren't actively moving through the dough on their own. They're mostly staying in place. It's the dough itself, the space between them, that is stretching and expanding. This is precisely what is happening in our universe. The galaxies are, for the most part, coasting along. It is the space between them that is continuously growing. This is where the speed of light rule comes in, and why it isn't being broken. The rule that nothing can travel faster than light applies specifically to things moving through space. It's a speed limit for objects on the cosmic highway. But the expansion of the universe is about the highway itself being stretched. There is no known physical law that limits how fast the fabric of space-time can expand. It can stretch at any rate. So, when we say the universe is expanding faster than the speed of light, we are talking about the cumulative stretching of space between very, very distant points. Think of it like this. Imagine you have two ants on a relaxed rubber band. They can only crawl along it at a maximum speed of, let's say, 1 centimeter per second. That's their speed of light. Now you start stretching the rubber band. The ants are still crawling at their own slow pace, but the distance between them is growing much faster because of the stretch. The space between them is expanding. If you stretch the rubber band fast enough, the ants could be moving away from each other at a rate of 1 meter per second, even though they are only crawling at 1 centimeter per second. Their speed relative to the rubber band hasn't changed, but the expansion of their world has made them separate at a much higher rate. This is exactly what happens with galaxies. A galaxy far, far away isn't firing its engines to zoom through space at an impossible speed. Instead, every single bit of space between us and that galaxy is stretching a tiny, tiny amount. But when you have billions of light years of space, and each little bit stretches, all those tiny stretches add up over such an enormous distance. The cumulative effect is that the galaxy appears to be receding from us at a velocity that increases with distance. At a certain point, that cumulative velocity exceeds the speed of light. This is not because the galaxy is moving that fast, but because the amount of space between us that is expanding is so vast. The scientist Edwin Hubble was the first to discover this phenomenon by observing that light from distant galaxies was shifted toward the red end of the spectrum. This redshift is similar to the Doppler effect you hear when an ambulance siren changes pitch as it moves away from you. The light waves are being stretched as the space they travel through expands, making their wavelength longer and redder. By measuring this redshift, we can calculate a galaxy's recession velocity. And the shocking discovery was that the farther away a galaxy is, the faster it appears to be moving away from us. This relationship is known as Hubble's law. Now, here's the real kicker. For the most extremely distant galaxies, we can observe that recession velocity is indeed greater than the speed of light. Their light is still able to reach us, but it's a race against the expansion. The light leaves that galaxy and begins its long journey across the universe. As it travels, the space behind it and the space in front of it is constantly stretching. This stretching elongates the light wave, sapping its energy and redshifting it over billions of years. Eventually, after an epic journey, that incredibly faint and redshifted light reaches our telescopes, telling us the story of an object that is now receding from us at a velocity faster than light. We are seeing its ghost, its image from a time when the universe was much smaller and it was closer to us. Furthermore, we've discovered that this expansion isn't just happening, it's actually accelerating. Something we call dark energy is acting like an anti-gravity force, pushing space apart faster and faster. Because of this, there is a cosmic horizon. There are galaxies so far away that the space between us and them is expanding faster than the light they emit can travel through it. Their light will never, ever reach us. They are forever beyond our observable universe, lost to us in the expanding darkness. The part of the universe we can see is finite, and it is actually getting smaller as more and more galaxies cross over that light speed horizon and disappear from our view. So, this incredible fact that the universe is expanding faster than the speed of light doesn't break physics. It redefines our understanding of reality. It tells us that the cosmos is not just a collection of objects in a void, but a dynamic, stretching fabric whose behavior is the most powerful force in the universe on the largest scales. It means that the universe has a history and a future that is dictated by the subtle properties of empty space itself. It is a humbling and awe-inspiring thought that we can piece this together from our tiny little world. The light arriving at our eyes today from the far reaches of the cosmos is a message from the past, telling us about the nature of space-time itself. Thanks for joining me on this incredible cosmic voyage. Take care of yourselves, stay curious, and I'll see you in the next video.